All right, we'll get started. Happy Friday, everybody, and hope your week's going well. Hope homework is coming along just fine. All right, let's take a look. Today I want to talk about tidying our data, and we're gonna be working with the tidyverse. I'm a big fan of the tidyverse, and a lot of today's lecture comes from this textbook, R for Data Science, written by Hadley Wickham and Garrett Grolman. They're part of the R Studio, or I guess Posit team there, and yeah, I'm a big fan. Highly recommend this book. You can read it for free in your browser. You can also go to the store and buy a physical copy. But yeah, this is a great resource. The tidyverse is kind of a collection of packages designed for data science, and it describes itself as an opinionated collection of packages, meaning that they have kind of this philosophy on how data should be organized, how you should create your tables and things like that. The packages, a lot of these packages you are familiar with. You have ggplot2, along with things like what we'll look at today, tidyr. Next week we'll look at dplyr. I've already introduced readr to you, okay? And then we'll also look at stringer next week. I won't get to per or forcats, but they are also part of the tidyverse, and if you have time to check those out, I recommend it. And today we'll look at tibble and tidyr, and we're really just kind of scratching the surface on these packages and what can be done with them. Okay, so let me talk about tibbles. Okay, tibbles are basically the tables or the data frame structure that we work with in the tidyverse. They operate and act very similar to data frames, but there's a few kind of tweaks or things about them, features that make our life easier. R is a little bit of an older language, and there's kind of a lot of old legacy code, and some of these things that were useful 20 years ago just aren't as useful today. And so a lot of innovation is happening, but in packages. And so the tidyverse is frequently changing, and so I frequently have to update my my notes here, because every couple of years they make a significant change to the tidyverse that says, okay, we're no longer using this function, we're now using this thing. And so using the tidyverse kind of requires you to kind of stay up to date on how the tidyverse works. But in my opinion, they've always kind of been innovating and doing kinds of neat stuff. So I recommend it. But yeah, the tibbles and the tidyverse, work similar to data frames, but not 100% the same. Okay, so here we're going to just create a tibble, much like we create a data frame, and what this will do is it will we're going to just kind of create five rows here, and the rows will contain time date information, also contain date information, just some integers, some random numbers, because here I'm just doing runif, random uniform numbers, and then we're going to also just contain some string data. And this is kind of much in the way that you would create a data frame. So a lot of times a data frame, you could specify, A is equal to, and you provided a vector, B is equal to, and you provided a vector. And basically, we're doing the same thing. Here I'm saying column A is going to equal a vector, B is equal to, another vector of length 1,000, and something like that. And this is what the tibble looks like when you print it out. And so a couple things that a tibble prints out that a data frame does not is, well, at the very beginning it says it's a tibble, and it gives you the dimensions of the tibble right at the top. It says, it's 1,000 by 5. Whereas, when you print out a data frame, it doesn't necessarily tell you the dimensions of that data frame. And here it says you have column A, B, C, and D, and E, and it also tells you the kinds of values in that column. So column A contains date time information, column B contains date information, C integers, D doubles, E characters. Okay, and it says there's 990 more rows to kind of indicate that that the table goes on. So I think by default, tibbles just print out the first 10 rows, or basically maybe more, but just whatever fits on the screen. Okay, I don't know if you've had the experience of trying to print out a large data frame. So, so if I do something like empty cars, right? It tries to print out the entire data frame onto the thing, and sometimes it kind of scrolls down. Let me see. It aims. No, I don't know what a good a thing is. But if I do say like tibble on MT cars, okay, this will turn it into a tibble, and then it basically just prints out what fits on the screen, right? And so here it just prints out the first 10 rows, says it's 32 by 11, 10 rows, and it gives us some information that wasn't there, okay? In the when you just print out a regular old data frame versus so if you just do empty cars, same kind of stuff, okay? One thing that tibbles don't do is it doesn't print out row names, okay? So data frames will sometimes have row names. Tibbles don't. Part of the tidyverse is that it doesn't like the idea of using row names. Like if you want row names, you should basically just create a column called name and put that information in there. Okay. So MT cars just has integer indices at 1 through 10 versus the tibble just has the integer indices versus over here it's got the actual row names and stuff. I guess another thing, tibbles will do is if you have if your screen is kind of small, and sometimes if you try to print out if you try to print out a data frame that's really wide, you'll get this experience where it prints out like some of the columns, and then because all the columns didn't fit, it spills over onto the next thing, and then it kind of spills over again and again. And if you do a tibble instead, it's only going to print what fits on the screen, and it stops. So it doesn't kind of flush out the entire screen with the thing. And it just says, hey, I was only able to fit these 5 columns, and we have 6 more variables here. So that's so tibbles are aware of kind of how big your screen is, and will only try to fit data that fits onto your screen. A difference between tibbles and data frames happens when you subset. And when you subset with single square brackets, tibbles will always return a tibble. Okay, so sometimes we're accustomed to data frames simplifying things when we select just a single column. So here I'm going to create a data frame, and this is what my data frame looks like. I've got 3 rows, column A and B. And if I do something like data frame, just select comma 1, single square bracket comma 1, it will select what? Column A, and by default it simplifies it to a vector of the values 1, 2, 3. Here I'm going to create a tibble. This is the resulting tibble. It's a 3 by 2, and it contains information, integers, and columns. And here I'm going to kind of subset using the same way. I'm going to say, whoops, I did double square bracket there. So if I take my tibble and I say I just want to select the first column, TB single square bracket comma 1, it always maintains that it's a tibble. Okay, so single square brackets, it will remain as a tibble. Now if you want to do some kind of vectorized operation with this, and you do want to get out the vector, you'd have to explicitly use a function like pull. And pull will take the resulting kind of column, and it will extract it out into a vector. Okay? That's different from a data frame, where you can have a data frame, and if you select one column doing comma square bracket comma 1, it just turns it into a vector. And you might say, well, that just makes my life harder, that I have to kind of pull things out. Okay? Yes and no. So with data frames, okay, if I do something like this, I want data frame 1:2, right? Then I'm going to end up selecting columns A and B, and this will be a data frame, right? And with a tibble, if I do 1:2, I'm going to get the same kind of result. Here, if I do comma 1, I get a tibble. Over here, if I do 1, I get a vector. The thing is I might do something like this, right? Columns to select. Okay, and I'm going to do this. Columns to select. So if I do this, columns to select will reduce down to a vector. Okay. If here I have a 1, 2 here, and I select the data frame doing columns to select, then I get a data frame, right? If you're running this code and you don't know right off the bat whether columns to select has just one value in it or two values, because it's created somewhere else, right? Somewhere else in your code, you're populating this variable, columns to select, and by looking at this thing, you don't know if there's just one value in there and it's going to select one column, or if there's 2 or 3 values in it and you're going to select multiple columns. And so when you see something like this, it is hard to predict. As you're reading your code, it's hard to predict, am I going to get back a vector or am I going to get back a data frame? Okay. With a tibble, whether columns to select has 1 value or 2 values in it or 3 values, you know that when you use a single square bracket, it will always return a tibble. Okay. I can change columns to select to just be 1 value, and it will be just one thing. So that's one thing about tibbles and working in the tidyverse, is that it remains consistent. Whether you're going to select 1, 2, or 3 values, okay, whether this vector columns to select contains 1, 2, or 3 values, its behavior is always going to remain the same. So yeah, you know what? If you're just using one number like this, sure, you can be like, oh, well, that's easy. I could figure out that this is always going to be a vector. I know that this is going to be a data frame. But again, if it's something like this, which is, I would say, not an uncommon thing to encounter, where you have some kind of variable and you're going to be using that to select your columns or something like that, then it starts getting a little bit shaky as far as like, is this going to return a data frame or is this going to return a tibble? So anyway, that's what you have. Now, if you do want this behavior where it does simplify, you can do subset it down to kind of one column, and you use the option drop equals true, and that will drop down the dimensions down to a vector. Okay, or again, you can use that function pull that will extract out that column there, and you have that. Okay, using double square brackets and $sign notation will always kind of reduce it down to a vector, because double square brackets, you can only pick one thing, right? You're looking at the contents of that train car or in the list, and so double square brackets will always reduce down to a vector. A $sign notation, you can only select one column at a time using $sign notation, so that will also always reduce down to a vector. Okay, so there's no ambiguity here. These we always know will reduce down to a vector. You can also, okay, so I showed you how to create a tibble, much like you would create a data frame using the tibble function. You can do a column name with the corresponding vector. Okay, you can take an existing data frame and just wrap it in tibble, and that will make a tibble out of the existing data frame. You can also use this function called tribble. Tribble, the R in the tribble stands for row, so row-wise, and so you are creating a tibble row-wise. And so here, if you just kind of want to type out your values, you can say column A has, and then column B, and then each row now corresponds to, or the new line and here corresponds to a row. Okay, and this is just kind of formatted for being easy on the eyes, but technically this is just kind of this sequence of values here. But the tibble will create this accordingly as well. Okay, let me give you your first view quiz answer, and that's going to be the letter E. E as in elephant. E is your first view quiz answer. One thing about tibbles that kind of throws students off is that by default it rounds, okay, but only when it's displaying information, okay? So just when it prints to the screen, it frequently rounds values. And so here I've got a tibble and it's got the values 9.8765432, and also the next value it has is 1.1234567. And by default, when you print out a tibble, it's going to round it off to say like 9.88 or 1.12. And you know, this makes a lot of students uncomfortable. The information is not lost. It is there, okay? It hasn't, it's not lost. If you were to say, hey, select column A and pull out this value or something like that, it's going to have the full thing. The extra decimal places are not lost there. But if you just want it to include this stuff as it's printing out, you can do something like pillar.sigfig and specify how many significant figures you want printed out. So here, if I say sigfig equals 5, it's going to do 9.8765 and things like that. So you can kind of, you do have control over this, but by default, it just kind of rounds down to you know, keep the tibble printed out into as compact as possible. Yeah.
If you extract the column out, is it going to display all the decimal points, or is it also going to, by default, print out?
So it will display all the decimal points. Let me see if I can. I'm having trouble selecting stuff here. Okay, so I'm going to copy this. Let me go to R here. So I'm going to call this TB for my tibble. All right, so this is what it looks like. TB, if I do TB select column A, okay, it looks like that. But then if I do say pull, it has the full, I don't know, can you see this? It's got the full value there, okay? So again, select, we'll select just your columns, or if I do, you know, TB square bracket first column, and I pull it, you know, this just turns it into a vector, and R's default behavior for vectors is to print out, I think, 7 or 8. I don't know how many significant figures. There's 1, 2, 3, 4, 5, 6, 7. I think R's default behavior is 7 significant figures. So there's technically a 2, but yeah, that's in there as well. Okay, I want to talk about pivoting data, and we're going to spend the rest of today's lecture talking about pivoting data. So the philosophy in the tidyverse is, you know, this is how you should store your data. And for your general basic table, it says every column in your table should be its own variable. Every variable gets one column. Every column contains only one variable. Every row gets one observation. Every observation is in one row. Okay, so row has one observation. An observation exists only in one row. And then every cell is a kind of a single value. Okay, that this idea of a cell being a single value is a little bit flexible. Okay, in that you can have tables where within a cell, that cell contains like another table, or perhaps like a list or something, but it's the idea that it's just one value, quote value, that is relevant to answering that question. That's kind of more like in this nested list thing. Okay. We are going to take a look at this package tidyr within the tidyverse. And you can read more about tidyr by going to, well, one is you can first go to the tidyverse, tidyverse.org, and again, this is their second edition, and this is my friend Mine. She graduated from UCLA, and she gets the author credit on the book. Oh, good for her. Okay, that's exciting. So in the packages, list of packages, there's a bunch of stuff, and we have the tidyr packages. There's several of these things that you can kind of read about, but we're going to look at the tidyr package, and this is where it says each variable is a column, each column is a variable, each observation is a relation. So this is kind of the philosophy of tidy data, right? To get it installed, you're going to do install.packages tidyverse. That will install the entire tidyverse into R. You could also just install just the tidyr package, but we're going to make use of the tidyverse. So just do install.packages tidyverse. And then here's a cheat sheet with a lot of kind of information. And it says tidyr functions fall into 5 main categories: pivoting, rectangling, nesting, splitting, and making missing values either explicit or implicit. And today's lecture is really just going to focus on pivoting, and there's still kind of a lot that we can talk about. Here, if you click on the cheat sheet, this is what it looks like. And again, our entire lecture today the rest of today's lecture will just be on this pivoting, pivot longer and pivot wider. But you can see there are a whole bunch of other things that can be done with tidyr, like splitting your cells, handling the missing values, expanding tables. There's things for dealing with nesting data and things like that. And so this is kind of transforming your nesting data. And so this is beyond what I'm going to cover today, but there is a lot of kind of interesting stuff, and I think this is worth checking out. Okay, so but anyway, let's talk about this. So here is a table, and this is an example of what we might consider tidy data. All right, we've got columns: storm, wind, pressure, date. Each column has one variable. Each row is an observation, and it looks like that. Okay, storm name, wind speed, air pressure, date gets its own column there. Here's an example of data that, I guess in one form we could say it's tidy. The columns being 2011, 2012, and 2013. But somebody might also say, you know what, the variables are the country. So we have France, Germany, and the U.S. DE is for Deutschland, so that's Germany, not Denmark or something. Okay, so this is the one variable is the country. Another variable we might consider to be what year was it. Okay, and if we say the variables are the country, the year, and then in the last case the last variable would be the number of cases. And in that case, if you said the variable is the year, then this is not tidy, right? Our variables are spread across 3 columns, right? So we've got country as one variable, and then the year spread across 3 columns, and then the count is kind of spread across these 3 columns, right? We've got the column for 2011, 2012, and 2013. So maybe we want to rearrange this data. Here's another thing, and again, we have three columns here, and you could say, well, this is tidy. You've got the city in one column, the particle size in another column, and the amount in the third column. But if you look at this, you've got large particle size, small particle size. We might look at this and say, you know what? The columns I should have I've got the city, and then I should have a column for a number of large particles, and I should have a different column for the number of small particles. So this could be something different, okay? And so we might look at this and say, here is, if you look at the data, it's kind of weird. We have two different variables, the amount of large particles and the amount of small particles in the same column here. And then if you wanted to kind of separate these out, like if I wanted to say, what's the difference between large particles and small particles in New York? That'd be tough to do, right? I would say I would do 23 minus 14, I have a difference of 9, but like I would have to kind of extract out the even rows versus the odd rows. And then once I do 23 minus 14, where does that number get stored? Does it get stored in row 1 or row 2 or both rows or something like that? It gets weird, right? So sometimes, so maybe this is the data that you want to work with in this form, but also maybe it's not. So we want the option to be able to kind of rearrange and have flexibility. Okay, these tables as they exist, these really small tables, they are little CSV files and they're available online, and so I could just read them in using read_CSV, okay? And so I read them in. They're into storms, cases, and pollution. Okay. When you have tidy data, you can do these vectorized calculations. So here was my storms data, and let's say I wanted to calculate another column based on wind and pressure. I can do that. When the data is tidy, I can do storms $pressure divided by storms $wind, and I could store that result into storms $ratio. And R does all of these calculations. It's vectorized and it works, right? So it just does 1007 divided by 110 gives me 9.1545. It does 1009 divided by 45 gives me 22.4, and so on and so forth. It calculates the new column, and that's nice. Okay, so it's a nice thing. Vectorized things, I can just add new columns. In dplyr, you can just call mutate, and it's going to create new columns when the data is in this form. So we like having each variable in its own column, allowing for these vectorized operations. Here is that table with cases, and again we have country, France, Germany, US, the column 2011 with 7,000, 5,800 cases, 15,000 cases, 2012, these were the number of cases, 2013, these were the number of cases. And let's say we wanted to rearrange this. So one column is country, one column is what year it was, and another column be the number of cases. If I do that, how many rows will I end up having in this rearranged table? 9 rows, because all of these things need to get rearranged. And so this diagram is actually a little bit wrong, because the resulting table will be France, 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 Germany, 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 US, US, US. And here I have it arranged the wrong way with 2011, 2011, 2011, then 2012. But anyway, the idea being each of these things, there were 9 cells here, and each of those are now going to get its own row. So we'll have France 2011, 7,000. And then technically it'll be France 2012 with 6,900, France 2013 with 7,000, so on and so forth. But we're going to rearrange this data. This is called pivoting our data longer. Pivot our data, and because the resulting table ends up being longer, this is called pivot longer. Okay? So we're going to take our cases table, the tables that are being kind of combined into, the columns that are being combined into one are the columns 2011, 2012, and 2013. Those columns are being combined, and so I specify columns 2011 : 2013, and the values in there get pivoted into one longer column. It says names to. We're taking the column names, and they end up in this one column. The column names 2011, 2012, and 2013 end up as the values in this column. And so what are we going to call that column where they go into it? That gets put into the column, and we're going to call it year, right? And that makes sense. What about the values? 7,000, 5,800, 6,900, 6,000. where do those values go? Okay, well, they get gathered together into one column, but what do we call that new column? We're going to call that new column cases. So names to year, values to cases. And the resulting table looks like this. We have 9 rows, 3 columns, country, year, cases. All right, so that's our data's been pivoted longer. Okay. So a little bit more data, or a little bit more information. Now the names that we selected, back when I did this, I did names to goes to year, values to goes to cases. These names are arbitrary, all right? There's no inherent meaning to these, to the names that we selected there that go into there. So if you wanted to call names to goes to the new column is going to be called when it happened, you can do that. Not a good name for a column because columns, we don't like to put spaces in our column names, but you could do that, okay? Values to, instead of cases, you could call it how many. And again, it'll do that. These are just completely arbitrary. There's no inherent meaning to year or cases. R or tidyr isn't aware of this. It's just gonna gather those columns together and do as you ask, and you get years and cases there. Okay. So yeah, these names are just arbitrary. You can do whatever you want. Okay. All right. Here's a question: what happens if I only pivot the columns 2012 and 2013? If I only pivot those columns. How many rows am I going to end up having? We'll end up having 6 rows. Okay, and then what will the columns be? So I'm saying names to year, values to cases. I'll have country.
2011, 2012, and then year.
Okay, let's see if this matches what you thought it would be. This is the resulting table. Okay, we get the column country, and then a column 2011, and then we're going to have year and cases. Okay, so we pivoted the columns 2012 and 2013. So those column headings end up in this new column called year, and we have 2012, 2013, 2012, 2013. The cases, those 6 cases get pivoted here. And what happened? Country gets duplicated. So we have France, France, Germany, Germany, US, US. And then the values in 2011 also get duplicated. 7,000, 7,000, 5,800, 5,800, 15,000, 15,000. Okay. Again, dplyr doesn't have any context, doesn't know what any of these columns mean. And so anything that doesn't get pivoted, it just ends up duplicating. So back here, I think it said, we thought like, okay, it made sense that France just gets duplicated across these three rows. Germany gets duplicated across these 3 rows. Here, France, again, the country values get duplicated, but anything I didn't pivot also gets duplicated. So that would include the column 2011. So this also appears like this. Okay, which we look at this and go, oh, that feels a little bit strange, but it's just doing exactly what we asked it to do. Anything that doesn't get pivoted just gets duplicated, and new rows are created. What would happen if I tried to pivot all 4 columns? If I pivot country, 2011, 2012, and 2013? How many rows would I end up having? How many columns would I end up having? I would have 12 rows, yeah. And then what would my columns be? It says names to name, values to value.
Every value of every column.
Yeah, so actually, what if you try to do this, you're actually going to get an error. It's going to say, I don't know how to combine characters and doubles because country is in character and these values are doubles. So if you try to do it directly, you get an error. But if we like force it and we just say like, make everything character so I can combine everything, then this would be the resulting thing. Okay, so I'm going to kind of force everything into character, and then I'm going to pivot all 4 columns. What ends up happening is I end up having 12 rows, 2 columns, a column for name, column for value. And then I get country, France, 2011, 7,000, 2012, 6,900, so on and so forth. And then this ends up being how the data gets pivoted. This is weird looking. This is not really useful. We've like overdone it. We pivoted too much, and now our data is not very helpful. But kind of from a theoretic standpoint, as far as like what is the operation that's happening, I think this also illustrates exactly what goes on when you pivot data and you say, I want to pivot these columns into one. It's going to say, yeah, sure, let's do it. And this is what happens. Okay, let me give you your second view quiz answer, the letter B. B as in bear. B is your second view quiz answer. Okay, let's look at this third table, pollution table. And so we have New York, large 23, New York, small 14, London, large 22, London, small 16, Beijing, large 121, Beijing, small 56. Okay. Okay, let's pivot this. So what we want to do is we want to create a column for large particle and a column for small particle. So rather than a column for particle size and a column for amount, we want to create a column for large particles and a column for small particles. So that way I can do kind of comparisons and say, hey, what's the difference between large particles and small particles in New York? What's the difference between large particles and small particles in London, things like that. So if I pivot this data, this is going to be called pivoting wider. How many rows will I have and how many columns will I have? We're going to end up having what? 3 rows. 1 row for New York, a row for London, a row for Beijing. And you have 3 columns. 1 for the city name, 1 for how many large particles we have, one column for city name, 1 column for large particles, 1 column for small particles. So this would be what our resulting pivoted data would look like. Okay, so how do we do this in R? We call pivot wider. We're going to pivot this table, pollution, and then we're going to say the names, the column names, come from the size column. It used to be the size column. We're going to take the values inside the size column to make the column names. The values that we're going to do will come from the amount column. So we're going to say the values come from the amount column. That's all we specify. So pivot wider, names from size, values from amount. And this is what we end up getting. Okay. Pivot wider is sensitive to any kind of spelling differences. It kind of goes through and it says, okay, well, we're going to look for unique values in here. And basically, each unique value gets its own row. And if it can kind of combine these things, it combines them. So what if our data, instead of saying New York and New York, we had NYC, right? So that's a common abbreviation for New York City. And so we might have this, and I say, all right, let's pivot this wider. What's going to end up happening here? How many rows will I end up having? I'll actually have 4 rows, all right? I'll have a row for NYC, a row for New York, a row for London, a row for Beijing, okay? And then the columns are still going to be city, large, and small. What's going to happen for NYC? NYC large will be 23. What about NYC small? It's going to induce an NA, right? It's going to say, well, there's nothing there. So that's exactly what happens. I end up getting 4 rows and 3 columns. NYC large is 23. NYC small is NA. New York large is NA. New York small is 14. Okay. But again, when you pivot wider, sorry, let me go back here. Again, when we pivot wider, we can do like a difference column, and we can do all of these things. But again, if something is spelled a little bit funny, it's going to induce NAs. So that could be a thing. Now, this could be a legitimate thing. So maybe it's not. Maybe you actually do have 2 separate locations, one being New York, and maybe this is actually like Los Angeles or whatever, and you just didn't have values for Los Angeles small or something, and then you have an NA. Sometimes you don't want NAs, or you know that it shouldn't be NAs, but we should actually put in a different thing. And so you can also do values fill. And instead of NAs, it would fill in these values. Yeah, question?
So what happens if, like, in size, like, you have an NA? Does it create, like, an NA column, or?
That's a good question. Let me, I'll have to try this out. I don't know. Will it create an NA column? I don't know. That's a good question. I have a different example, but not that exact example. Let me, we can try it out. Okay, but let me talk about this. So here I got values fill, and here I say values fill 0, and instead of NAs, I put in zeros. Now, you should only do something like this if you know that it should be 0, okay? Don't just replace, so NAs sometimes make your life a little bit inconvenient, okay? They are a little bit inconvenient, having missing values inconvenient. And so it's tempting to do some kind of quick operation so they go away and you can kind of do your calculations. But that kind of thing to just kind of make these NAs go away could end up like messing up your analysis. Like if you put in a 0 here, like let's say instead of NYC I had Los Angeles. Los Angeles large might be 23, and maybe I just don't have a number recorded for Los Angeles small. It's probably wrong to say there's 0, okay? 0 pollution or something. We just didn't record it, or something went wrong. And so to put it 0 in there is probably the wrong thing to do. And then, but if you do have a 0 in there, now your mean calculations, like if you calculate the mean of this thing, that 0 is gonna throw things off. It's gonna affect it. So putting in an actual number could mess things up. So you only want to do that if you know that is the correct thing to do, to replace the missing values with some actual number there. Okay. Kind of going along with this, a similar thing, but different is if in the small size column, if I put in large, all caps large here, all right, and then I say pivot this wider, what's going to happen now we end up getting a column for all caps large. All caps large, column for small, lowercase small, column for lowercase large. And then we get NAs induced in these places where the values don't exist. So, so you want to be just be mindful of that. Okay, so that's pivot wider. Pivot longer and pivot wider, these are like inverse operations. So here's my original pollution table, and I said, hey, let's pivot this wider, and we get 3 rows, columns city, large, and small. And I'm going to store this as table W. And if I want to get this original table back, here's table W, and what I can do is I could say pivot this longer. Pivot the large and small columns longer, put those into column small and the values into column amount, and we kind of get the inverse, right? So I could start off this and end up here. I could start off with this and end up here. So pivot longer and pivot wider are inverse operations. In the same way, here is the cases table, and what I showed you is that we pivoted this longer and this is what we produced. But again, I could take this thing and I could pivot it wider. All right, so I could take the long version of the table and I can also pivot it wider, and I end up with this. So they're inverse operations. And so just depending on how you want to deal with this, like you might actually want your data in this form so you can calculate the difference between what happened between 2012 and 2013, okay? You might also want it this way, all right? You might want to do some summary aggregated information. So later on in we'll learn dplyr, and you want to do something like group by country, group by year. And in that case, you can kind of like aggregate this thing, all right? And you want it in this form. Similarly with this, you might want it in the wider form so you can calculate differences between large and small. But in some cases, you might want it in this form. So having this flexibility to kind of pivot your data wider or longer is very useful. And again, this is all just part of dplyr, and we really just learned these two functions, pivot longer and pivot wider, which are shown on the cheat sheet. There's a few other functions I didn't cover, but sometimes you have columns, and you want to kind of just merge them together into one value. So here you have century 19 in year 99, century 20, year 00 or something like that. And you want to kind of just unite them together, like collapse them by strings or something. You can do that unite. Okay. Sometimes you have a column and you want to separate them, and there's some kind of like delimiter, like a slash, and you can do that. There's separate longer and things like that. So these are functions here. On the second page, this deals with nested stuff. And so sometimes within, you can have a nested data frame. All right. So here we have Amy, Bob, and Zeta. Okay. And you might want to kind of nest these 3 rows into a single kind of cell here, so that each one can be extracted into like its own little table. And so you can kind of nest these things here. And so these are things that you can kind of look at. These pictures kind of show you in quick what's happening, and you'd have to kind of read up the corresponding documentation. Let me go back to this question that we had regarding like what happens if one of our columns were NA. Let me give you your third view quiz answer. Third view quiz answer is the letter A. A as in apple. Okay, so the question is, what would happen if, like, instead of large, we had an NA? So let me just go to pollution. And what I want to do is first row, second column, I want to kind of put in an NA. All right, so this is what we have. And we're going to ask this to pivot wider pollution, and we're going to do names from, size, and values from. Gotta load up tidyr. Okay, yeah. So if you have if a column is NA, and you do pivot wider, then you'll get a column for NA. So you'll have an NA column, a small column, and a large column. So it's I guess treated much like this was just a different spelling of something else or some other new entire category, but it treats it as this column is called NA. So that's what would happen. This is what you were asking? Okay, yeah. So that's what would happen. Okay, that's it for today. I think I gave you all 3 view quiz answers, so we'll wrap it up here. I guess finish a minute early. Have a good rest of your day. Have a great weekend, and we'll see you next week.